with the value of L that we have found in part 2, we are supposed to prove this equation here by making use of the mathematical induction. In order for me to prove this, I need to first find what is the smallest possible n, and I'll make sure that for the smallest possible n, it is going to be true. The smallest possible n that I can see is 1, so I'm going to try to first prove that P1 is true. So P1 on the left hand side, is U1, and U1 is already given to me by the question as 2. So this is given. Then I'm going to look at what is on the right hand side. Right hand side is going to be equal to 14 over 3, 1 over 2 to the power of 1 minus 1 over 3. This I'm going to have 7 over 3 minus 1 over 3. It is going to be 6 over 3, which is 2. And this is the same as the left hand side. That is why from here I know that P1 is true. The next few steps, of course, we can try to prove that P2 is true by making use of the same method. Then P3 is true, P4 is true, P5 is true. If you just keep continuing and just keep getting all the equations to be true, maybe one day you'll be able to convince the world that this Pn is definitely true for all n belonging to a positive integer. But what we're going to do is something that is even more elegant than this, something that is really efficient. It is by making use of the process of mathematical induction. To do that, I'm going to make an assumption. Since we have already found out that P1 is definitely going to be true, I'm going to assume that Pk is true, but not for any k, but for some of the k values, which is also belonging to this n values over here. So for some k, that is also going to be positive integer. What I'm trying to say is that Uk, it is going to be equal to 14 over 3, 1 over 2 to the power of k minus 1 over 3. And what is my aim? My aim, it is actually to try to prove, take note, Pk is just an assumption, we have never really proven this, but what we're going to prove, it is the next term, which is the Pk plus 1 proposition. So my aim is to prove that Pk plus 1 proposition is true. That means I'm going to aim to try to prove that Uk plus 1 is equal to 14 over 3 of 1 over 2 to the power of k plus 1 minus 1 over 3. In order for me to prove this, I'm going to make use of the recurrence relationship, to bring in the expression of Uk into the Uk plus 1 equation here. Looking at the left hand side of this, it is Uk plus 1. I'm going to try to prove that it is the same as the right hand side, so making use of the recurrence relationship that is given to me by the question. Uk plus 1 is going to be equal to 3 times of Uk minus 1 divided by 6. And what is Uk? Uk, we have already assumed that it is this. So it is 3 times of 14 over 3, 1 over 2 to the power of k minus 1 over 3 minus 1 divided by 6. If I were to multiply this in, it is going to be 14 over 3 times 3. I'm going to leave this 14 over 3 here, because this portion here has a 14 over 3. So multiply by 3 times 1 over 2 to the power of k. This and this will be minus 1. Then minus 1 divided by 6. This divided by this is going to be 14 over 3. 3 over 6, it is 1 over 2. Then 1 over 2 to the power of k. And this is minus 2. Minus 2 divided by 6 is minus 1 over 3. And this is 14 over 3. This and this, it is 1 over 2 to the power of k plus 1 minus 1 over 3. And this is equal to the right hand side. What we have just done here, it is actually to prove a relationship. A relationship that we managed to establish that is between the Pk plus 1 proposition and the Pk proposition. Because of the recurrence relationship that we have used here, in order for us to prove that Uk plus 1 is true, we have made use of the fact that Uk is true. And without proving Uk, that is why as long as I manage to establish a relationship that is like this, with P1 that we have proven, Okay, and at the same time, with this relationship that I've also proven, it will together tells me that if P1 is true, then P2 is going to be true. So if P2 is true, it will automatically help me to induce that P3 is going to be true. Okay, that is why I can now say that Pk plus 1 is true, okay, if Pk is true. Okay, this is the relationship that we have formed. So since we have also managed to prove that P1 is true, okay, so by the process of mathematical induction, okay, by this process, we can then say that P2, P3, P4, and all the way, okay, as long as A are all positive integers, okay, P, that means the entire Pn is going to be true, okay, for all the n's that are positive integers.